Okay guys, so today we're going to be looking at the third part of section 2.2. The first thing we're going to be trying to do is to find the points at which functions have horizontal tangents. Then we're also going to use points to find the average rate of change as well as the instantaneous rate of change. So our first goal here is we could be given some function, maybe it looks like this. We want to know where do we have horizontal tangents. Well, right here the slope is positive, positive slope. But right here, can you see how right there we're going to have a horizontal tangent? The slope right here, the tangent line's negative, 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 but then right here we're going to have a horizontal tangent. Positive, positive, positive. So the question is, if I give you a function, how can we find what these points are that create the horizontal tangent? Is there anything you know about these points? Yeah, Casey? Right. The slope of that horizontal line has to be 0. What have we been working with that tells us slope? The derivative, correct. So then how are we going to do this? We're going to take the derivative, and then what would we set it equal to? 0, right. That's how we're going to find where we have a horizontal tangent line. So in our first function, we want to take the derivative. Peter, tell me the derivative. Okay, so that's it. That's going to be our derivative. So once we have our derivative then, what do we say we're going to set it equal to? 0. So we're going to set this equal to 0. So now we've got these two functions right here, these two parts. And how are we now going to solve this? What would we need to do with this? Casey? Okay, we could also take a 4 out too, right? So let's go ahead and factor a 4x out. And when we do that, we're going to have x squared minus 4. So now we want to know what's going to make this equal 0, so we have to keep factoring. So x squared minus 4 is the difference of 2 squares. That's x plus 2x minus 2. So there are actually 3 factors, so we should have 3 solutions then. And what are those 3 values going to be? Paige, what are the 3 values that are going to make it equal 0? Good. So those are the x's that create us having the horizontal tangent line. That's where we have the horizontal tangent. Now, it says that we have to find the points, though. So we want to write these as points. So 0, comma, I'm going to plug that back into this function. So I'm going to have 0 to the 4th minus, this is going to be 0 as well, plus 2, so 0, 2. Now I have to plug in negative 2. Negative 2 to the 4th is going to be 16. Negative 2 squared is 4, times negative 8 is going to be minus 32, and then plus 2. So that's negative 16 plus 2, so that's going to be negative 14. How do I know that positive 2 is also going to give us negative 14? Even function, right. If it's an even function, this exponent's even, this exponent's even, this exponent is 0, so it's also even. Therefore, I do not have to even substitute it back in. I'm done. There are the 3 points. Now, we should also know how to check this. If I look at this function, I should be able to tell that that's where we have the horizontal tangents. So I'm going to go to y equals, I'm going to type in the function and see if it does indeed appear that we have horizontal tangents there. And we can have the calculator even find these for us. So here's the way the function looks. I can't really quite see the bottom of it, so I'm going to extend the y min down to like negative 15. I'll go negative 16 just to make sure. So here's what it looks like. So it kind of looks like we have horizontal tangents at those points, but can you see how this would actually be a low value? This is what we call a minimum. This is called a local maximum, and this is called a local or relative minimum. So if I can just find those points, I can figure this out. So I can do second trace, I can tell it to find the minimum, and I know the minimum is at negative 2, negative 14, at least that's what I want to check. Instead of scrolling over to my left bound, I'm just going to insert negative 3. And my right bound, I'm going to just put in the number negative 1. I don't have to scroll around, I'm literally typing it in. And so now it's going to say, is your guess in between those two? Yes, it is. Enter. And so now I can see that my minimum value is at negative 2, negative 14. Remember, calculus gives us the exact result. The calculator is just trying to count pixels, and it's not using calculus. So therefore, our answer is better. Just checking this one real quick. I think it's at 0, so I do second calculate. This is going to be a maximum, so I go to number 4. For my left bound, I think it's going to be in between negative 1, oops, enter, and 1 is my right bound, and then it says, is it in between those two? I push enter, and it tells me this is my maximum. Now, if you gave me this answer, 2.27, e negative 6, comma 2, that's wrong. Here's the reason why. The calculator, again, is estimating 2.28, basically, e negative 6. What that means is it's 2.28 times 10 to the negative 6. That means I take this and I move it over 6 spots. This is what it's telling me the answer is, or the x. So that's 0, guys. Again, the calculator is estimating on this graph. That point is 0, 2 exactly. All right. For the next one, we're going to try to figure out where we have a horizontal tangent. So again, we have to take the derivative. This is just kx. Kx. Kyle, what's the derivative of this then, if it's radical 3 theta? Okay, well, if it's just k theta though, the derivative is just going to be k, so it's just going to be a radical 3. The derivative of anything x is just the anything. It's just the constant. So the derivative here is just going to be radical 3. We don't even have to write it as to the 1/2. It's not necessary. The derivative of 2 sine theta. Jackson, what's the derivative of 2 sine theta? Right, so plus 2 cosine theta. Again, we're trying to find where we have a horizontal tangent. That means where do we have a slope of 0? So I'm going to plug in 0 here. We have to solve this, so we're going to subtract the radical 3, divide by 2, and look at our restriction. It says in between 0 and 2 pi. Okay, so we have to know where is cosine equal to negative radical 3 over 2? In between 0 and 2 pi. Maybe some of you know this. If you have the unit circle memorized, you probably already know this. But if you don't have it memorized, you draw a picture. We're going to think radical 3 over 2, we want it to be negative. So we have negative radical 3 over 2 in the second quadrant. We would also have, should be better, but anyway, you get the idea. Let's just do a circle, or a triangle rather. So we're going to have negative radical 3 over 2. And down here, we would also have negative radical 3 over 2. So our missing side then would be the 1. So across from the 1 is 30 degrees. So then I have to think, well, what's this angle? But I need it in radians. So in radians, 30 degrees is pi over 6. So I know this has to be something times pi over 6. But this is 180 minus 30, which is 150. is my angle. So 30 times what would give us 150? 30 times 5. So this is 5 pi over 6. This angle is going to be 180 plus 30. What's 180 plus 30? 210. It's a 30-degree reference, so it has to be something. This is 30. It has to be 30 times what would give us 210? 7. And so those are the two theta values. But we have to find the actual points. So one of my points, the x-coordinate or my theta coordinate, is 5 pi over 6. The other one, my x-coordinate, is 7 pi over 6. Here's what I have to do now to find the y-coordinate. I have to plug back into the original. So I'm going to have to do f of 5 pi over 6. So I have radical 3. Wherever I have a theta, I'm going to plug in 5 pi over 6 plus 2 times the sine of 5 pi over 6. That's what I have to evaluate in order to be able to find the y-coordinate. Well, this is just radical 3 times 5 times pi over 6. So that's just going to be 5 pi radical 3 over 6 plus. But over here, I have to figure out what is the sine of 5 pi over 6. So looking right here, what's the sine of 5 pi over 6? What is that? It's just 1/2, isn't it? So I'm going to have 2 times 1/2. So then 2 times 1/2 is 1. And so this point's going to be 5 pi radical 3 over 6 plus 1. This other point, I'm going to have to plug in 7 pi over 6. So I'm going to have to do f of 7 pi over 6. So I have radical 3 times 7 pi over 6 plus 2 times the sine of 7 pi over 6. Well, this is just going to be 7 times pi times radical 3, so that's going to be 7 pi radical 3 over 6. The sine of 7 pi over 6, what's the sine of 7 pi over 6, guys? Negative 1/2, so I'm going to have 2 times negative 1/2, and that's just going to give me minus 1. Guys, that's a tough problem, but that's something you have to be able to do. That will come up again on a quiz or a test, so make sure you can do that. There's going to be a couple on your homework, so make sure you don't skip those just because they're difficult. Okay, next, average rate of change. Average rate of change is always just going to be y minus y over x minus x. They're saying that if it's written like this, where we have c sub 1, f of c sub 1, c sub 2, comma, f of c sub 2, that's just going to be our second y minus our first y over our second x minus our first x. So this example, it says, find the average rate of change of the function over the indicated interval. So we're going to do that first. This is our interval from 2 to 3. So we have to figure out, first of all, what our points are. This is our x sub 1, or in this case, our c sub 1. This is our c sub 2. See, it's saying that our x is going from 2 to 3, but we have to find out what the points are. This is not a point. This is over an x interval. So I have to plug in 2, and I have to plug in 3, and find those points. So go ahead and do that, guys. Plug in 2 and plug in 3. And Dow, what'd you get when you plugged in 2? 2. All right. And Haley, when you plug in 3? 7. So these are our 2 points. So now we can find the average rate of change. We'll just abbreviate that, AROC, average rate of change, from 2 to 3. So all we have to do is 7 minus 2 over 3 minus 2, and that's going to give us 5. Now the second part of the problem says compare this average rate of change with the instantaneous rate of change at the endpoints of the interval. How did we say we find instantaneous rate of change? Derivative, right. So I have to find the derivative of this function. So f prime of t. Lauren, what's the derivative of this? Be 1 times 2, it's 2t, not just t. So 2t is going to be our derivative. And so then I want to find the derivative or the instantaneous rate of change at 2, so I do f prime of 2. Plugging that in, 2 times 2 is 4. I want to find f prime of 3, and so plugging that in, it's going to be 2 times 3, which is 6. So here's our instantaneous rate at 2, instantaneous rate at 3. What do you notice about these instantaneous rates of change compared to the average rate of change? Isn't it true that if I average these instantaneous rates of change, I would get that average rate of change? Yeah. So this just ends up being the average of these two. All right, let's find our average rate of change here. So to find our average rate of change between 1 and 2. So first we have to come up with the points. Sarah, what do I get if I plug in 1 into the function? And what about if we plug in 2 into the function? Michael? Okay, so now we have our 2 points, so we can find our slope or our average rate of change. So it's going to be -3/2 minus -3, which is +3, over 2 minus 1. Well, 2 minus 1 is just 1, so we really are just going to have whatever the answer is to the numerator. And so, Madison, what's that going to be? 1.5 or 3/2? Good, either one. So that's our average rate of change from 1 to 2. Now we have to find our instantaneous rate of change. Nick, what do we do to find that? Take the derivative. So we've got f of t. We have to find f prime of t. So I have to rewrite this. I have to think of it as -3t to the -1. Kyle, can you think of the derivative of that? If you do -3 times -1, and then t, and then you have to subtract 1 from the exponent. So that's going to be our derivative. That's going to tell us the instantaneous rate of change. So now we have to find that derivative at 1 and that derivative at 2. So we have to do f prime of 1. That's the instantaneous rate of change at 1. F prime of 2. That's going to be the instantaneous rate of change at 2. Avery, what do you get if you plug in 1? Isn't it just positive? Yeah. Positive 3? Yeah. And then what about if we plug in 2? What are we going to get there, Mendel? And once again, if you were to add these up, you get 3.75, and then take half. That didn't work that time, does it? So it's not always going to be this case that this average rate of change is going to be the average of these two, but sometimes, like in this case, it was. It depends on the type of graph we have. So don't fall for that it's always going to be the average of the instantaneous change at the endpoint. We may have questions. All right, you have your assignment on your assignment sheet, so make sure you get that done. We're going to check all that on Wednesday. Make sure you also are aware we do have our quiz over this is on Wednesday too. If you look at your assignment sheet, we've got Matho, we're going to review a little bit, and then we'll take our quiz. So make sure you can do everything that has been on the notes, and then also everything that we've done in homework.